In this video, we're going to talk about 6.2 Objective 3, where we use the theoretical methods and counting rule for outcomes to determine probability. Let's look at our first question here. How many different arrangements of males and females are possible in three-child families if the birth order is taken to account? What is the probability of a three-child family with exactly three females? Assume that none of the children are intersex. So we have the possibility of all male children, a male, and then a female, a male, a female, and then a male, a female, and a female, and then two males, a female, male, and a female, a female, and a male, and then all females. 1, 2, 3, 4, 5, 6, 7, 8. Got all 8 options. There are 8 options, and I know that because there's 2 choices, male or female, for each child, and there's 3 children. So there's 2 to the third, or 8 possibilities there. What is the probability of having exactly 3 females? There's 1 of those out of 8, so 1/8. Use the theoretical method to determine the probability of the following outcome and event. State any assumptions made. We're going to toss 2 coins, and we want to find the probability of getting 1 or 2 heads. So we can have heads, 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 tails, tail, heads, or tails, tails. At least 1 head is going to be those 3 out of 4, and we're going to assume that the coin is fair and it's equally likely to land on heads or tails. That's what fair means. So the probability is 3 out of 4. Use a theoretical method to determine the probability of the given outcome or event. Assume that the die is fair, meaning that it's equally likely that it'll land on any of the 6 sides. Rolling a single 6-sided die and get a 2, 3, or 4. Those are 3 out of the 6 outcomes, so 1/2. Use the theoretical method to determine the probability of the following event. A randomly selected person has a birthday in September. So we're going to take the number of days in September, which is 30, divided by the number of days in a normal calendar year, which is 365. We're not including leap years. And we're going to reduce that fraction to 6 out of 73. Experiment consists of drawing 1 card from a standard 52 deck of cards. What is the probability of drawing a queen? Well, there's 4 queens in that 52 card deck, so we're going to divide by 4, and we get 1 out of 13. Use theoretical method to determine the probability of the outcome given below. The next president of the United States was born on a Thursday. Using all days of the week as equally likely, Thursday is 1 out of 7 days of the week that they could be born on. Use a theoretical method to determine the probability of finding the next person you meet has the same birthday as yours, ignoring leap years. State any assumptions that you make. So the probability should be 1 out of 365, since there should be, on average, normally 365 days in a year, and we're assuming that it's equally likely for people to be born on any day of the year. So that's this one. Use the theoretical method to determine the probability of the outcome or event. Bag of 20 red candies, 10 blue candies, 5 yellow candies, means that there's a total of 35 candies in the bag. What is the probability of getting a red candy? It's 20 out of 35. And we're going to round this to the nearest thousandth. So that's 7,571. Then 10 out of 35 is going to be 286. And then yellow is going to be 5 out of 35 is 1/7, which is 0.143. And the probability of not yellow is going to be 1 minus 0.143 is 0.99. And this is 0.857, which should be the same answer as if I added these first two numbers together here. And it is. All right, suppose that you randomly select, this is like the first problem, assume that the births of males and females are equally likely. We're just going to make a chart here. It says 3 females, 2 females, 1 male. One female, 2 males, and then 3 males. And if we go back and we look at our list that we made up here, there was 1 out of 8 ways to get 3 females and 1 out of 8 ways to get 3 males. That leaves us 6 ways to get 2 females, 1 male, 1 female, 2 males. They're equally divided. I'll show you. So 2 males and a female, 1, 2, 3, and then 2 females and a male, 1, 2, 3. So they're both 3 out of 8. And that is this first one right here. They all add together to be 100%. There are 8 possible birth orders. Probability of 2 males and a female is 3 out of 8. Probability of a female, a male, and a female is in that order is 1 out of 8. At least 1 male is going to be 7 out of 8, because that's going to be 1 minus all females. And then probability of at least 2 females should be 1/2. Yes, right here should be 4 out of 8, which is 1/2. And that's it for this video. And we will come back next time and talk about 6.2 Objective 4. See you for the next video.